Hello everyone. Hello everyone. Good afternoon. How are you today? How was your test? Yes. How was your test today? So how was your test? Yes. Yeah. So today we are going to talk about your test discussion, the test paper discussion. Very less time is remaining for us for our examination. Okay. So we need to practice more and more problems. Okay. Now let's start with our today's session. We are going to talk about and we are going to solve the questions. Okay. So you can solve those with me also. If you have any doubt, you can ask anytime. Okay. So let's begin. The first question here is what an acidic buffer solution can be obtained by mixing of a solution of. So here by mixing we can obtain which type of solution. We need to obtain which type of solution here, acidic solution. Okay, acidic buffer. We need to find out the acidic buffer solution. So with the help of which we can take acidic buffer sodium hydroxide and ammonium chloride, barium cyanide and hydrogen cyanide, right? Then barium cyanide and hydrogen cyanide, then sulfuric acid and sodium sulfate, then sodium hydroxide and sodium chloride. So there are various options given. Among these, what do you think is what acidic buffer? So when we talk about the buffer solution, you can see here ammonium hydroxide and ammonium chloride. This is what basic buffer because base is present there, ammonium hydroxide. Okay, so here barium cyanide and hydrogen cyanide, when we talk about this, you can see that this is what our acidic buffer present here. Okay, by mixing these two solutions, we are going to get the acidic buffer. Right. Next problem is what primary and secondary valences of chromium according to the Werner theory in the complex is. So this is our complex dichlorido oxalotochromium 3. And we need to find out which are the primary valences and secondary valences here. Okay, so here when we talk about the primary valency is nothing but the oxidation number of a central metal atom. So here chromium, how much is the oxidation number? It is what? 3. So this is the oxidation state for this given element. Okay, for this given atom. So the primary valency will be 3. Here the compound contains Cl minus ion and C2O4 2 minus ion as ligand. Here Cl minus ion is what? Unidentate ligand. On the other hand, C2O4 2 minus is what? Bidentate ligand. So that's why the secondary valency will become 6 because Cl minus are present how much? 2 and C2O4 2 minus are present how much? 2. Right? Di are present. So 2 into 2, 2 plus 2, there are 4 and 2, there are what? 4 plus 2, 6. Secondary valency will be 6 and primary valency will be what? 3. So what is the answer here? We need to find out primary and secondary. Primary is 3 and secondary is 6. So option C is what? Correct answer here. Any doubts, everyone? Okay, let's move on to the next problem. Yeah. 80 ml of O2 takes 2 minutes to pass through the hole. What volume of SO2 will pass through the hole in 3 minutes? Okay, so here we need to consider the diffusion. Rate of diffusion is rate of diffusion of one atom on one molecule with the respect to rate of diffusion of another molecule. Okay, that is equal to what? Volume by T1 divided by volume by T2. Right? Volume of first molecule divided by time taken for that given molecule divided by volume of second is equal to divided by the time taken for their displacement, okay, or diffusion. And that is what inversely related to the molecular mass of that given compound. This is, we know, rate of diffusion. Okay, so here what is given is we have given that for first element or first molecule, which is what? O2. It takes 80 ml. For 80 ml, it takes how much time? It takes 2 minutes. But for how much ml, we need to calculate for how much ml, what volume now. So how much ml, we will need 3 minutes when the molecular weight are what? SO2 and O2. So SO2 का molecular weight कितना है? SO2 का molecular weight, how much is it? And for O2, how much it is? It is 32 for O2, and for SO2, it is what? 64. Do this calculation, na, you will get V2 is equal to what? 120 divided by root 2. You will get 120 divided by root 2. So what will be the answer here for 53 question number? It is what? Option A. Just do the calculation. यहाँ पे आ जाएगा root 2. यहाँ पे हमारा 80 by 2 मतलब 40 आ जाएगा. 40 multiply by 3 आ जाएगा. Right? So ये हमारा 120 by root 2 आ जाएगा volume. Yes? Any doubts? Okay. Next problem. ठीक है, यहाँ पे देखिए 1 mole of an ideal gas is allowed to expand reversibly isothermally at 27 degrees Celsius until its volume is tripled. So here volume, first of all, it was initially it was 1 from, suppose it is having certain values. Okay, initially it is V1 and it has been tripled. Okay, 3 times of VI. It has been tripled from its initial condition. Okay, and we need to calculate the delta S of system. So you know delta S is what? Q reversible by time. And what is Q reversible? It is nothing but the work done. So what is the formula for work done? 2.303 RT log of V2 by V1. We know here what is log of V2 by V1. So 2.303, R का value लिखिए 8.314. Temperature is 27 degrees Celsius. That means in Kelvin it is 300 Kelvin. And log of how much? 3. And in the problem it is given log 3 is what? 0.48. So just put all the values here 0.48. And when you do all the calculations now, you will get answer something. Okay, whatever will be the answer, that will be your Q reversible. Okay, to that answer just divide it by, or in order to obtain the Q delta S for system, just divide it by 300 Kelvin. Okay, just divide this by temperature, that is 300. So what you are going to get is 300 यहाँ का cancel हो जाएगा. It's 0.48 into 8 into 2.303. When you do this calculation now, you will get your answer, that is equal to 9.1315 joule per mole per Kelvin. Why I have taken here joule? Because R ka value is what? In terms of joule per Kelvin per mole. Okay, so when you do all this calculation now, you will get 9.1315. That is option B. Okay, that is option B. Any doubt regarding here the problems? Solutions? Right? Yeah, let's move on to the next problem. Which of the following species have electrovalent, covalent, and hydrogen bonding? So when we talk about the bonding in a given molecule now, here you can see option C, in which CuSO4 5H2O, it contains electrovalent as well as covalent as well as hydrogen bonding. You can see here the hydrogen bonding I have shown. Okay, covalent bonding I have shown, coordinate covalent bonding, that is electrovalent bonding. Here covalent bonding also you can see. Yeah, any doubt in this? Yeah, let's move on to the next problem. So here simply option C is the correct answer. Next, which of the following species has no d electrons in the central metal atom? So here we need to consider which molecule doesn't contain any d electrons. So when we find out the oxidation state for each and every central metal atom, for titanium, for chromium, for copper, and for potassium, you can find out here that for option B, that is K2CrO4, here chromium is in +6 oxidation state. Okay, it is in +6 oxidation state, and as we know, chromium is having electronic configuration. When chromium is only there, na, we know it is what? 3d5u4s1. So it is actually total electron present are what? 6, and all the 6 electrons are what? They are present in the bonding, and that's why chromium forms +6 oxidation state here. Okay, it needs to form +6 oxidation state in order to form this type of complex. So that's why here in d orbital there are 0 electron present for this molecule. For titanium, for chromium, and for copper, here there is not observed that d orbitals are, they have certain electrons in d orbital. Okay, these elements have certain electrons in d orbital, but this molecule doesn't have. That's why this will be our answer. Okay. Yeah. Next, the oxidation number of oxygen in KO2 is. So you know KO2 molecule, this is what? Superoxide molecule. Okay. So KO2 is what? Superoxide. Oxidation state of oxygen here is what? -2. So -2 is equal to what? 0.5. So we can say that here oxidation state for oxygen in KO2 is 0.5, and for K it is what? +1. Please remember this. Okay. Any doubts so far? Next problem. Which one of the following complex is an outer orbital complex? So A, B, C, D, 4 options are given. Which among these is outer orbital complex. Outer orbital complex means what? Which uses the outer d orbitals in order to form the bonding with the respective ligands, copper, manganese, iron, or nickel. So see here, you can see complexes on hybridization of central metal atom. Here, when this molecule, when this complex form, it uses inner d orbitals. When this molecule form, it uses inner d orbital. When this molecule forms, it uses inner d orbital. But for the fourth molecule, okay, option D में क्या हो रहा है? Nickel uses its outer orbital d orbitals. Okay, outer orbital electrons, outer d orbital electrons, and that's why that will be our answer, option D. Okay, any doubts? Yeah, let's move on to the next problem. The complex form in Mond process has. So here, when the Mond process takes place, the complex form is what? NiCO4. Okay, this is the complex which is formed during Mond process. Okay, and the structure of that is what? Tetrahedral. Okay, the structure of it is what? Tetrahedral. Okay, any doubts in this? Next, hybridization and geometry of PF5 molecule are. So we need to find out what will be the hybridization for this molecule. So as we know, phosphorus is from what? Nitrogen family. So for carbon, there are valence electron 4. For nitrogen, it is what? 5. So for phosphorus also, valence electrons are what? 5. So write down 1, 2, 3, 4, 5 electrons. Okay. Then each electron get bonded with the fluorine atom. Okay. So how many bonding pairs are present here? 5 bonding pairs are present here. So that's why the hybridization will be what? sp3d, because 3 and 1 4 and 1 5. Okay, this will be the hybridization. When it will be sp3d1 is the hybridization, that is sp3d, then you know the shape of a given molecule is what? Trigonal pyramidal. Trigonal bipyramidal. So that's why option A is what here? Correct answer. Okay, everyone, any doubts? Next problem. Check most probable condition for ionic bonding. You know that Fazan's rule. Yeah, you know Fazan's rule. What is the Fazan rules? It says that if the given ion is having low charge, okay, we are having low charge on ions, large cation and small anion, then there will be what? Good ionic bonding will be present in the given molecule. So that is what option A is the correct answer here. Low charge on ions, large cation and small anion for ionic bonding in terms of Fazan's rule. Next, total charge required for the oxidation of 2 moles of MnO4 2 minus into MnO4 minus. So here what is happening? MnO4 2 minus getting converted into MnO4 minus. During this conversion, now 1 electron has been, what is happening? 1 electron is what? Change occurring. But the thing here given is what? 2 moles. So if these are 2 moles, if these are 2 moles, then what will happen? 2 electron change is going to take place. So we need to consider here 2 electron change. If you are considering 2 electron change, now you can see here for 2 moles, total charge required will be what? 2F. Okay, total charge required will be what? 2F. Any doubt in this? So here answer will be what? Option C. Yeah. Next problem, which is correct regarding the physical adsorption of gas on surface of liquid. So here we need to find out which is not correct. Okay, physical adsorption के बारे में कौन सी बात यहाँ पे बराबर नहीं है, that is not correct. On increasing temperature, adsorption increases continuously. Enthalpy and entropy change is negative. Adsorption less specific in nature of gas, reversible. So here option, which option is not correct, we need to find out. On increasing temperature, adsorption increases continuously. So we know that adsorption is what? Ability of substance to concentrate or hold the gases, liquids or dissolved substances upon its surface. That is what the adsorption. So it decreases, means adsorption, which statement is not correct here? On increasing temperature, adsorption increases continuously. This statement is not correct. Okay, because we have seen in adsorption phenomena that this doesn't happen. Okay, even though you increase the temperature, adsorption is not going to increase. Okay, so these are what? This is what? Not correct statement. We know this is true statement. Entropy and enthalpy both are negative values. Okay, adsorption less specific in nature of gas. So this is again true, and you know that adsorption is, physical adsorption is reversible. Okay, yes. Next, 67 problem. You can see here, metal crystallizes into FCC and BCC lattice with age length 45 angstrom and 3 angstrom respectively. The ratio of densities of DFCC or DBCC will be. So, you know, density of FCC divided by density of BCC. Okay, here which rule we need to use here? Densities are equal to what? The age length of a given Z for FCC. Okay, number of atoms in FCC crystal lattice divided by number of atoms in BCC crystal lattice. Here multiplied by A cube of BCC, right? This is our formula, and A cube of FCC. Yes, any doubt in this? Yes, right? So number of atoms in FCC are what? 4. Number of atoms in BCC are what? 2. A का वैल्यू BCC का दिया हुआ है 3 एंगस्ट्रॉम, एंड बी का FCC के लिए हम लोगों को क्या लेनी है वैल्यू 4.5 एंगस्ट्रॉम. यहाँ पे 45 हो गया है, वो गलत है, ठीक है. 4.5 एंगस्ट्रॉम लीजिए for calculation. When you do all the calculations here, na, after doing the calculations here, you can observe that you are going to get the answer in terms of, so यहाँ पे लिखेंगे 4 into 3 का cube divided by 2 into 4.5 का cube. Okay, after doing all these calculations, you will get answer 0.59. Okay, and that is equal to this fraction. Okay, and that is equal to this fraction, that is 16 by 27. So here option D is the correct answer. Okay, any doubts? Yeah. Okay, let's move on to the next problem. The vapor pressure of a pure liquid A is. So for pure liquid A, the vapor pressure is given, that is what? 70 torr. Okay, that is at around 27 degrees Celsius, means 300 Kelvin. It forms an ideal solution with another liquid B. So A क्या कर रहा है? Ideal solution form कर रहा है with liquid B. The mole fraction of B is given, that is what? 0.2. Okay, mole fraction of B is given, that is 0.2. Total vapor pressure of the solution is 84. So total vapor pressure दिया हुआ है हम लोगों को. Total pressure is equal to what? 84. So what is the vapor pressure of liquid B here? Okay, so you know our formula, mole fraction of A plus mole fraction of B is equal to 1. We know that mole fraction of B is how much? 0.2. So what will be the mole fraction of A? It is what? 0.8. Yes, any doubt in this? Very simple. You know that PA, that is what? Vapor pressure of a molecule is what? 70 torr. Okay, vapor pressure for A is 70 torr. What will be the vapor pressure for another molecule? As we know, total pressure is what? 84. So from Dalton's law of partial pressure, we know that total pressure is equal to PA plus PB. Right? Any doubts in this? Now we know that from Raoult's law of vapor pressure is that pressure is equal to what? Vapor pressure into mole fraction. So pressure is what? Vapor pressure is what? 70, and mole fraction is what? 0.08. So we can find out the partial pressure for that given molecule, PA. Again, from Raoult's law, vapor pressure for B molecule will be what? P0B into 0.2. We don't know the vapor pressure, and that is what we need to calculate. So ये वैल्यू हम लोगों को पता है, ये वैल्यू हम लोगों को पता है. इसमें कि हम लोगों को कौन सी वैल्यू पता नहीं है? जो हमारा वेपर प्रेशर है ना, वो हम लोगों को पता नहीं है, बाकी हम लोगों को सब पता है. So just put that value here. You can find out that by doing all the calculations, we are getting the answer 140 torr. Yes, everyone. Any doubts in this? Very simple, very good problem actually, right? You will need hardly 1 minute for this. Okay, just remember x a is xp. यहाँ से आप easily calculate कर सकते हो. Partial pressure का हमारा formula है pressure of A component plus pressure of B component. ठीक है, that is what total vapor pressure हम लोगों को already solution का दिया हुआ है. ठीक है, तो इस तरह से हम लोग ये calculation कर सकते हैं. 140 torr, that is option C is correct option here. Okay, option C. Yeah, next. The oxidation potential of hydrogen electrode at pH 12 and pH 2, that is pressure is given, it is 1. So we need to calculate here what? Oxidation potential. So what will be the oxidation potential for this given molecule? Okay, so here you can see pH is what given? 12. pH is given 12. H plus ion कितना हो जाएगा फिर? 10 raised to minus 12. ओके pH 10 है तो हमारा H प्लस आयन कॉन्सेंट्रेशन कितना हो जाएगा 10⁻12. We know the formula, we know the oxidation reaction which will take place around hydrogen electron. Okay, in the hydrogen electron, in this way the electron is going to lose. So using the Nernst equation, we know this Nernst equation, H plus ion concentration divided by what? Pressure of H2 gas. So that is 1. And what is the H plus ion concentration? 10⁻12. Okay, 10⁻12. So that is what our this one, what we can say, this is what our log. ठीक है, ये log होने के बाद when we calculate this ना, तो minus 0.0591 multiply by -12 आगे आ जाएगा, तो इसका हम लोग -12 कर लेंगे और log of 10, right? log of what? 10. So ये कैलकुलेशन कीजिए, कैलकुलेशन करने के बाद आपको क्या आंसर मिलेगा, देखिए 0.0591 multiplied by 12. You will get answer. It is equal to how much? It is equal to minus plus हो जाएगा. That is equal to 0.7092. Okay, 0.0 plus 0.7092, and it will be in terms of volt. That's why here option C is what our correct answer. Yeah, any doubt in this? Yes, simple है. Formula use करना था सिर्फ. ठीक है. Then next problem, very simple. Pi bond is formed by overlapping of, you know, pi bond is formed by the overlapping of pp orbital in which way? Sideways, right? In the sideways manner. So that's why option D is the correct answer here. Yeah, any doubts? Let's move on to the next problem. Okay, IUPAC name of the compound shown below it. So here this is our compound and we need to calculate the IUPAC name for this given molecule. You know that we need to start the numbering from a given group, from a given functional group at which it will have the lesser numbering. So यहाँ पे आप लोगों को दिख रहा है डबल बॉन्ड प्रेजेंट है, तो हमको इधर से नंबरिंग स्टार्ट करना पड़ेगा. ठीक है, 1 2 3. सो थर्ड नंबर पे ब्रोमो आ रहा है, फर्स्ट नंबर पे क्लोरो आ रहा है, तो क्लोरो लिख लो, बाद में ब्रोमो लिख लो. ठीक है, बट यू नो दैट अकॉर्डिंग टू व्हाट अल्फाबेटिकल ऑर्डर, बी पहले आता है, सी पहले आता है, बी पहले आता है. दैट्स व्हाई आवर नेम विल बी 3 ब्रोमो देन 1 क्लोरो. Right? What is the name of this given compound? Cyclohex, right? Cyclohexane है, लेकिन वहां पे क्या है, हेक्सेन में क्या है, एक डबल बॉन्ड प्रेजेंट है ना, सो इट इज हेक्सीन. और इन किधर प्रेजेंट है, 1 कार्बन पे, सो 1 इन. ओके, हेक्स 1 इन, साइक्लो. ठीक है बच्चों, ये हो गया हमारा आंसर. सो व्हाट इज द ऑप्शन हियर? 3 ब्रोमो 1 क्लोरो साइक्लो hexene. Okay, option C. Yeah, any doubts? Bromo 1 chloro cyclohex 1 in. So यहाँ पे 3 लिखो. Okay, next. Which of the following compound is not aromatic? So here we need to find out which compound is not aromatic. So you know that in order to have a compound to be aromatic, it should contain 4n plus 2 pi electron. It should be containing 4n plus 2 pi electrons. So here this is aromatic, we know. Here we know this is aromatic, right? We know this is aromatic. So which one is not aromatic here? Option A is not aromatic. Okay, because it contains only 4 pi electron. That's why it is what? Anti-aromatic in nature. Okay, so this species A is what our not aromatic species. Next, IUPAC name for this given compound. So if we start numbering from this side, 1 2 3 4 5 6 7. So you can see at the 4th position, these substituents are coming and this substituent are coming at the 5th position. So ये numbering नहीं चलेगी क्योंकि numbering हमारे substituent को सबसे लेट जा रही है. ठीक है, तो मैं क्या करती हूँ, इस numbering को बदल के another way से numbering देती हूँ from this side. 1 2 3 4 5 6 and 7. Now you can see the numbering is closest to the substituents. So 3 ethyl, 4 4 dimethyl. This is what? Heptane. So here answer will be what? Option B. Any doubts? Yes. Very simple problem, everyone. Okay. So option B will be the correct answer here. Yeah. Yeah. Let's move on to the next problem. देखो मैंने यहाँ पे अच्छे से आप लोगों को स्ट्रक्चर ड्रॉ करके दिखाया है. Okay. Next, the increasing basicity order of the following compounds is 1 2 3 4. So यहाँ पे we need to find out the increasing basicity order. First molecule दिया हुआ है, second, then third, then fourth. So here increasing basicity order for this molecule will be like this way. First of all हमारा आएगा molecule कौन सा, ये कितने नंबर का molecule है, 1 2 3 4. Yeah, can you tell me? So increasing order of basicity is what? Like this way. CH3, CH2, NH, CH2, CH3. So this is which molecule? Second molecule. Okay, then this is what? First molecule. Then this is what? Third molecule. And this is what? Fourth molecule. ठीक है, तो यहाँ पे बेसिसिटी की जो ऑर्डर है ना, वो ऑर्डर हमारी इस तरह से होगी. ठीक है, एनी डाउट्स इन दिस? Why is it happening? Because बेसिसिटी मतलब क्या? नाइट्रोजन के जो लोन पेयर है वो इजीली अवेलेबल होने चाहिए. नाइट्रोजन के लोन पेयर इजीली अवेलेबल कहाँ पे होंगे? देखिए अवेलेबल कहाँ पे हो रहे हैं वो? There will be what? A nitrogen atom which will have the easily availability of this electron. वो easily donate कर सकेंगे. तो आप लोग यहाँ पे देख सकते हो कि फोर्थ मॉलिक्यूल जो है हमारा, उसमें क्या हो रहा है? ये जो नाइट्रोजन पे लोन पेयर है वो क्या है? वो दे सकता है इजीली. दैट्स व्हाई इट इज व्हाट? गुड बेस. ओके, नेक्स्ट मॉलिक्यूल जो हमारा होगा ये होगा. यहाँ पे भी क्या हो रहा है? ये यहाँ से डोनेशन, यहाँ से डोनेशन, यहाँ से डोनेशन. तो ये जो इलेक्ट्रॉन है ये इजीली नाइट्रोजन दे सकता है क्योंकि उसको डोनेशन बहुत ज्यादा है, इसलिए थर्ड आएगा. पहले फोर्थ, उसके बाद आएगा थर्ड. नेक्स्ट क्या है हमारा? ये मॉलिक्यूल, इस पे दो सब्स्टिट्यूएंट प्रेजेंट है, एक हाइड्रोजन है, सो वो आ जाएगा सेकंड मॉलिक्यूल. नेक्स्ट लास्ट में ये मॉलिक्यूल आ जाएगा प्राइमरी अमाइन क्योंकि उसको सिर्फ एक ही सब्स्टिट्यूएंट प्रेजेंट है. आर यू गेटिंग इट? सो अवर करेक्ट ऑप्शन विल बी ऑप्शन बी. ये जो ऑर्डर यहाँ पे लिखा है ना, ये थोड़ा यहाँ पे नाइट्रोजन का जो स्ट्रक्चर है वो बिगड़ गया है, इसलिए ये इस तरह से हो गई है. ठीक है, तो ये आप मत देखिए. ठीक है, ये जो हमारा आंसर है इस तरह से होगा. ऑप्शन डी हमारा करेक्ट आंसर होगा. ठीक है, नेक्स्ट, विच ऑफ द फॉलोइंग इज मोस्ट रिएक्टिव टुवर्ड्स इलेक्ट्रोफिलिक रिएजेंट? सो इलेक्ट्रोफिलिक रिएजेंट के लिए हमारा इनमें से कौन सा मॉलिक्यूल ज्यादा से ज्यादा रिएक्टिव होगा? ठीक है, फॉर रिएक्टिव, टू बीइंग अ रिएक्टिव मॉलिक्यूल वी नीड टू कंसीडर हियर ऑल द substituents present. Okay, CH3O, CH3, CH3, NH, CH3OH, CH3 and CH2OH. So we know that due to plus M effect of OH group present here, okay, and hyperconjugation due to CH3 group, here the compound B, okay, option B will be most reactive towards the electrophilic reagent. Okay, towards the electrophilic reagent हमारा जो compound B होगा ना बच्चों, वो क्या होगा? ज्यादा रिएक्टिव होगा towards the electrophilic reagent. Okay, due to the plus M effect of OH ions as well as OH group and hyperconjugation due to CH3 group. Any doubts in this? Let's move on to the next problem. Which of the following processes does not increases the amount of CO2 in atmosphere? Decay of animals, photosynthesis, breathing and burning of petrol. Here we need to talk about do not increase. Okay, do not increase the amount of CO2 in atmosphere. So what do you think? Which process do not increase the amount of CO2 in atmosphere? Yes, so you know that photosynthesis, which is largely happen every day around us, is what? Photosynthesis process in which plants uses CO2, okay, to make food for the growth of the given plants, to make food for the growth of their own growth. Okay, growth of the given plants. So हमारा जो photosynthesis process है वो हमारा यहाँ पे आंसर हो गया. Next, among the following compounds, the one that is most reactive towards electrophilic nitration is benzoic acid, toluene, next nitrobenzene and benzene. So यहाँ पे हम लोगों को आंसर देखना है. देखिए, ये है हमारा टोल्यून, ये है हमारा बेंजीन, ये है हमारा बेंजोइक एसिड और ये है हमारा नाइट्रोबेंजीन. ठीक है, यहाँ पे CH3 ग्रुप है, यहाँ पे कुछ भी नहीं है, यहाँ पे COH है और यहाँ पे NO2 ग्रुप है. ओके, हम लोगों को देखना है इलेक्ट्रोफिलिक नाइट्रेशन प्रोसेस होना चाहिए. ठीक है, सो इलेक्ट्रोफिलिक नाइट्रेशन होने के लिए हमारा जो टोल्यून मॉलिक्यूल है दैट इज मोस्ट रिएक्टिव, दैट इज व्हाट? मोस्ट रिएक्टिव टुवर्ड्स इलेक्ट्रोफिलिक नाइट्रेशन प्रोसेस इंस्टेड ऑफ बेंजोइक एसिड, NO2 एंड बेंजीन. ठीक है, अगर ये चारों मॉलिक्यूल यहाँ इलेक्ट्रोफिलिक नाइट्रेशन के लिए प्रेजेंट होगी तो हमारा जो मॉलिक्यूल कौन सा अंडरगो होगा नाइट्रेशन में? टोल्यून होगा, क्योंकि उसके पास क्या है? प्लस आई इफेक्ट वाला CH3 ग्रुप है. ये जो COH और NO2 ये क्या है? ये COH और NO2 क्या करेंगे? ऑलरेडी ये बेंजीन से क्या करेंगे? हमारे इलेक्ट्रॉन पुल कर रहे हैं. दैट्स व्हाई द रिंग इज बिकम ऑलरेडी इलेक्ट्रोफिलिक इन नेचर. तो उस पे इलेक्ट्रोफाइल कैसे क्या एक्ट करेगा? NH3 इज व्हाट? इलेक्ट्रॉन डोनेटिंग ग्रुप. सो इलेक्ट्रॉन वो डोनेट कर रहा है, इसलिए ये न्यूक्लियोफिलिक है सिस्टम. ओके, सो न्यूक्लियोफाइल के साथ इलेक्ट्रोफाइल इजीली रिएक्ट हो जाएगा. दैट्स व्हाई टोल्यून इज अवर करेक्ट आंसर. Right? Next, 78. Consider the following statement and select the correct option. So here S1, S2, S3, S4, these are 4 statements given and we need to consider the correct option. Okay, we need to consider here correct option. So dust is a non-viable particles. Non-viable particles. Particulates acquire negative charge and attracted by positive electrodes. O2 is a greenhouse gas and algae is a viable particulate. So here the first statement, that is what, dust is non-viable particle. This is correct statement. Okay. Another second statement is again correct. Negative particle are attracted towards a positive electron. This is again correct. O2 is greenhouse gas. This is not correct. Okay. O2 greenhouse gas nahi hai. Next, algae is viable particulate. This is again correct. So S1, S2 और S4 ये तीन स्टेटमेंट हमारे करेक्ट है, इसलिए हमारा करेक्ट ऑप्शन क्या आ जाएगा यहाँ पे 78. Next, out of the following alkene that exhibits optical isomerism. So हम लोगों को 4 alkene molecule दिए गए हैं यहाँ पे, you can see, and we need to find out which is going to show us the optical isomerism. So do you know what is the answer? Any answers from your side? Yes, alkene that exhibits optical isomerism. Optical isomer means what? Which will rotate the plane polarized light when it is passed through it. D conformer, L conformer, 3-methyl 2-pentene, 3-methyl 1-pentene, 4-methyl 1-pentene, and 2-methyl 2-pentene. So here we need to consider which compound contains a chiral carbon in it. Which compound contains a chiral carbon in it, then only it will be optically active. So here you can see 3-methyl 1-pentene. Okay, 3-methyl 1-pentene. That is option what? C. That is option C. 3-methyl 1-pentene. The molecule structure you can see here. This is 3-methyl. Okay, 1, 2, 3, 4, and 5. Here 3-methyl 1-pentene structure you can see. It is containing this another group, this another group, this another group, and this another group. So this carbon is what? Chiral carbon. Is what? Chiral carbon, and due to the presence of chiral carbon, it will be optically active. So option C is what correct answer here. Any doubt? You can try and find out the structures of these, and you can check whether they contain chiral carbon or not. If they are not containing chiral carbon, and that's why we are not choosing them. Okay, आप draw करो इनके structure, आप ये दे सकते हो. You can observe that they do not contain any kind of chiral carbon in them. That's why they are not optically active. Yeah, any doubts here? Yes? Do you understand this? Okay, let's move on to the next problem. What is the final product of a given reaction? So here we need to find out the final product for this reaction. You can see alkyne is reacting with sodium, and then it is reacting with what? Ethyl iodide. Okay, what will be the product? So see here reaction, you can see sodium, what is going to do? Sodium is going to abstract the hydrogen atom present here in the alkyne group. Okay, and it is going to form species like this way. This species next, upon reacting with the ethyl iodide, it removes iodide from it, and CH, this compound, this species attacks on that given carbide. Okay, ये जो हमारा anion form होता है उसपे, and we get the higher alkynes as a product. We get the higher alkynes as a product. So we need to see which molecule is this. Question 18. What will be the answer? A, B, C, D. Yes. Can you tell me what is the answer? A, B, C, D. So here option D. You can see CH3C, triple bond C, CH2 and CH. So option D is what our correct answer. Next problem, which of the following compound will exhibit geometrical isomerism? You know geometrical isomerism, cis and trans, right? We need to consider here cis and trans. So 1-phenyl 2-butene, 3-phenyl 1-butene, 2-phenyl 1-butene, and 1,1-diphenyl 1-propane. So molecules containing a double bond is what? 1-phenyl 2-butene, right? 1-phenyl 2-butene, you can see the structure of it. 1-phenyl, CH2, CH, double bond, CH, CH3. So you can see here molecule. Okay, here in this molecule, what is happening is 1-phenyl, CH, CH, and CH3. Right? So here you can see 1, 2, 3, 4. So 1-phenyl 2-butene, ये हमारा स्ट्रक्चर है. ठीक है, 1-phenyl 2-butene ये हमारा स्ट्रक्चर. यहाँ पे देख सकते हो आप हाइड्रोजन एक साइड में मैंने अगर किया, so we get cis molecule. If I put hydrogen at the different side and the substituents at the different side, we are getting trans isomer. So this is what our correct molecule, which is showing cis as well as trans isomer. That's why option A is the correct option here. Yes, everyone, any doubts? Okay, let's move on to the next problem, 82 number problem. Yeah, T and A. Next, which of the following is most reactive towards SN2 reaction? So we know if for SN2 reaction, we need to consider a substituent or a species which is having what SN2 reaction में किस तरह से हम लोगों को substituent चाहिए, which are what primary. Okay, primary होंगे उस तरह से. In SN2 reaction, what happens is there is a formation of primary carbocation and that favors the reactivity of a given SN2 reaction. Okay, in SN2 reaction, you know, the rate of a given reaction depends upon the nucleophile as well as on the reactant molecule, and that's why it is known as SN2. Okay, nucleophilic substitution reaction, bimolecular reaction. Here you can see here this molecule is donating molecule to this given halide. Here no substituent is present. Here this molecule is what withdrawing chlorine deactivates the ring, you know that, and NO2 is again deactivates the ring. So which deactivates more? So you know more deactivating it is what? NO2 group. So NO2 group being a minus I effect, what happens is that what it does, हम लोगों को अच्छा इलेक्ट्रोफाइल चाहिए क्योंकि सब्स्टिट्यूशन किसका होने वाला है, न्यूक्लियोफाइल का होने वाला है कि न्यूक्लियोफाइल is going to substitute on a given compound. So we need to have a good electrophile. So what NO2 is going to do, it is going to pull the electron density towards itself. Okay, so that's why what is going to happen, the more good charge is going to form on this given benzylic carbocation, and that's why the nucleophile can easily attack on this, and so that option D will have or will be having the most reactivity towards SN2 reaction. Yes, any doubts in this? Yeah, next problem. Okay, the compound X in the reaction. So here anhydrous AlCl3 reacting with ICl. Okay, so what will be the compound X? So A compound hoga, B compound hoga, C compound hoga, या फिर D compound hoga. So here you can see when this anhydrous AlCl3 react with ICl, na, what happens is that there is a production of electrophile that is I plus. Okay, so this is what aromatic electrophilic substitution reaction. Okay, here what happens is that I plus electrophile forms and it attacks on the benzene ring, and there is a formation of iodobenzene, right? There is a formation of iodobenzene. So here our correct option, that is option B, will be the final product X. Yes, everyone? Yeah. Next, aldehyde react with alcohol in presence of dry HCl gas to form aldones, ketones, acetals, none of these. So you know aldehydes, H, CO, H. Okay, I will write here CH3. This is our aldehyde molecule. It reacts with alcohol, that is ROH molecule, and it forms which type of compound? Aldehydes form करते हैं, ketones form करते हैं, acetal form करते हैं, या कुछ भी नहीं form कर सकते. So here you can see when aldehyde reacts with the alcohol, na, it forms OR and OR. So here what happens is that CH3 CO होता है और ये OR यहाँ पे अटैक होता है. ठीक है, अगेन थोड़ी देर बाद क्या होता है, ये रिएक्शन कंप्लीट होने के बाद यहाँ पे O माइनस हो जाता है, फिर से अनदर मॉलिक्यूल आता है अल्कोहल का, वो अटैक करता है. Okay, it is going to attack on this given molecule. Again, what is happened, it is going to go and there will be formation of CH3 C, 1 minute, CH3 C, OR, and here OR, and one hydrogen atom as it is. Okay, so this is what OR, ये क्या हुआ ना हमारा acetal, one type of molecule that is going to form, and which is what? Acetal. So here option B is correct answer. You know this, right? Yeah, you know this? Okay, now let's talk about the next problem. The direct iodination of benzene is not possible because iodine is an oxidizing agent. Resulting iodobenzene is reduced to benzene and HI. HI is unstable. The ring gets deactivated. Okay, the ring gets deactivated. So, इनमें से direct iodination of benzene कहाँ पे possible नहीं है? Okay, direct iodination of benzene is not possible. Why? Because it results into formation of this molecule, which reduced into C6H5 and HI. So this reason is correct option here. ठीक है, इसके वजह से हम लोग direct iodination नहीं कर सकते. We need to do the further another reaction and then we need to do the iodination on the given benzene molecule, क्योंकि ये जो iodobenzene है वो reduced हो जाता है. ठीक है, this reaction takes place very fast and that's why we cannot wait at this position of iodobenzene. Okay, guys. So option B is the correct answer here. Next, At 3000 Kelvin, the equilibrium pressure of CO2, CO and O2 are 0.6, 0.4, 0.2 atmospheres respectively. The Kp of the reaction will be. So this is our reaction. You know that the equilibrium constant is equal to product divided by reactant. Okay, product divided by reactant. So here pressure we need to talk about because we are considering the pressure constant. So here pressure of product divided by pressure of reactants. Okay, pressure of product कौन से हैं? CO है product में और O2 है. CO का क्या है 0.4, O2 का क्या है 0.2 और CO2 का क्या है हमारा 0.6. So put करो those values. Let's just put all the values. Okay, here you can see pressure of CO. कितना है pressure of CO? उसके 2 मोल से इसलिए मेरे यहाँ पे 2 लिए. O2 कितना है 1 ही इसलिए यहाँ पे 1 हो गया. CO2 कितने मोल से 2 मोल से. जो भी प्रेशर से उनका वो आप पुट कीजिए. CO का कितना प्रेशर है 0.6. ठीक है, CO का कितना है 0.6. देन इसका कितना है 0.4 और इसका कितना है 0.4 एंड इसका है 0.6. तो यहाँ पे हमारा कैलकुलेशन हो जाएगा 0.2 मल्टीप्लाई बाय 0.6 डिवाइडेड बाय 0.6. ठीक है, हमारा क्या आ जाएगा 0. CO का है हमारे पास 0.4 मल्टीप्लाई बाय 0.2 डिवाइडेड बाय 0.6. यहाँ पे है इसका स्क्वायर, यहाँ पे इसका स्क्वायर. डू ऑल दिस कैलकुलेशंस ना, यू विल गेट आंसर अकॉर्डिंग टू ऑप्शन ए. ठीक है, इसका आंसर आप लोगों को मिल जाएगा ए आंसर. ठीक है, कैलकुलेशंस कीजिए 0.4 इंटू 0.4. ओके, 0.4 इंटू 0.4 इंटू 0.2 divided by 0.6 into 0.6. When you do all these calculations now, you can find out that the answer is what? Option A. 0.4 into 0.4 into 0.2 divided by 0.6 and divided by 0.6. So we'll get answer 0.0088. We'll get answer 0.088. Okay, that is around 0.089. Right? Any doubts in this, everyone? Yeah, let's move on to the next problem. That is 87 number problem. So here you can see what is happening. Which of the following statement is not correct about the hydrides of group 15? So yesterday only we have talked about the hydrides, right? Can you tell me the answer? Yes, hydrides of the element group 15 are ionic and have planar triangular shape. Next, thermal stability of the hydride decreases down the group. Basic character of the hydride decreases down the group. Reducing nature of the hydrides increases down the group. Yes, so which are correct here? This is correct, and this is correct. So which is not correct, everyone? This. They are ionic and they have planar triangular shape. So this is not correct statement. Okay. Other statements are all true. Thermal stability hydrides goes on decreases down the group. Basic character also goes on decreases down the group. Reducing nature on the other hand increases down the group. Right, but their shape is not planar triangular shape and ionic. It is not like that. Okay, you know that. Next, the chemical reaction given here proceeds as follows. So एक fast reaction, एक slow reaction. Rate of the expression कितना होगा यहाँ पे? You know, rate of reaction always directly proportional to the slow reaction of a given total reaction. ठीक है, हमारा यहाँ पे क्या हो जाएगा, जो हमारा रेट ऑफ रिएक्शन है वो किस पे डायरेक्टली प्रोपोर्शनल होगा? हमारे स्लो रिएक्शन पे. ठीक है, हियर यू कैन सी रेट विल बी इक्वल टू के ऑफ O3 एंड O. सो हमारा रेट क्या हो जाएगा? इट इज डायरेक्टली प्रोपोर्शनल टू द रिएक्टेंट मॉलिक्यूल प्रेजेंट एट द इन दिस रिएक्शन. ठीक है, डायरेक्टली प्रोपोर्शनल टू दिस. रेट विल बी डायरेक्टली प्रोपोर्शनल टू ये जो रिएक्टेंट मॉलिक्यूल हो जाएंगे उनपे, उनके कॉन्सेंट्रेशन पे डायरेक्टली प्रोपोर्शनल होगा. डायरेक्टली प्रोपोर्शनलिटी साइन मैंने रिमूव कर लिया और यहाँ पे मैंने लिख लिया के. ठीक है, तो O3 और O का कॉन्सेंट्रेशन हम लोगों को यहाँ पे पुट करना है. At that step only we don't need to stop. So O3 and O का कॉन्सेंट्रेशन पुट करने के लिए आपको पता है O का कॉन्सेंट्रेशन हम लोगों को इस रिएक्शन से मिल रहा है. So for that you can put that in order to find out the concentration of O, you can find out the rate for this given reaction. So what is that? It is directly proportional to O3. Right, it is directly related to the change in the concentration of O3. So I have directly written, okay, directly written its rate that is equal to minus of, that is what, K double dash O3. तो मैंने K dash लिख लिया, हमारा K double dash भी लिख लिया, O3 डिवाइडेड बाय O2 कर दिया. O2 क्यों कर दिया? क्योंकि हमारा मॉलिक्यूल क्या हो रहा है वहां पे, एक तरह से हम लोगों को ये रिएक्शन में वो मिल भी रहा है और एक तरह से इस रिएक्शन में वो क्या हो रहा है, जा भी रहा है, ठीक है, फास्ट एंड स्लो प्रोसेस. सो पुट ऑल these things and you can find out the rate for a given reaction here is what? Option B. O3 का स्क्वायर then O2 का raised to -1. Yes, everyone, very simple reaction. Okay, you need to find out the rate for the slow process. After finding that, just put the value of O, concentration of O in this given equation and you will be finding out the answer. Right? Next reaction, sorry, next problem. What is the oxidation state of iron in the brown ring complex? So this is our complex. ओके, ब्राउन रिंग कॉम्प्लेक्स है हमारा. इसमें आयन का ऑक्सीडेशन स्टेट कितना है बताइए? +1, +2, +3, +4. Yes, so here you can see hydrogen water molecule is neutral in nature, right? NO is positive ligand, that is one ligand present, that's why plus charge. SO4 is what? 2- in charge. Okay, -2 charge. So what will be the charge on the iron? It will be what? +1 in charge. So that's why here answer will be what? 1. Yes, everyone, क्योंकि इस पे 2- चार्ज है, ठीक है. ओवरऑल मॉलिक्यूल पे कितना चार्ज है? कॉम्प्लेक्स पे 2+ चार्ज है, तो यहाँ पे प्लस चार्ज है, तो इस पे भी क्या होना चाहिए? +1. तो दैट मीन्स व्हाई इट विल बी हैविंग +2 चार्ज. तो +1 चार्ज होगा हमारा यहाँ पे. यस, एनी डाउट्स? नेक्स्ट प्रॉब्लम. Milk is an example of, so this is very simple problem. Okay, milk is an example of positive sol, emulsion, gel, both A and C. A and C मतलब positive सोल भी और emulsion भी. क्या है हमारा मिल्क? यस, वो जेल है क्या? आप लोग रोज देखते हो मिल्क को. व्हाट इज दैट? इट इज इमल्शन, पॉजिटिव सोल और जेल, और बोथ ए एंड सी. यस, सो मिल्क क्या है हमारा? पॉजिटिव सोल भी है और मिल्क क्या है हमारा? इमल्शन भी है. सो दैट्स व्हाई हियर ऑप्शन बी विल बी द करेक्ट आंसर. Okay, next. Benzene and toluene form nearly ideal solutions. At 20 degrees Celsius, vapor pressure of benzene is 75 torr and that of toluene is 20-22 torr. The partial pressure of benzene is at 20 degrees Celsius for solution containing 78 gram of benzene and 46 gram of toluene in torr is. So here we need to find out the partial vapor pressure for benzene. So here you know the formula, just we have solved one problem regarding this. So total pressure is equal to vapor pressure into right? The partial pressure is equal to vapor pressure into what? Mole fraction. So PV will be equal to what? 78/78 divided by 78, 78 plus 46/92. ये हम लोगों ने कैलकुलेशंस कर लिए. मल्टीप्लाई करो उसके क्या दिया है हम लोगों को? 75 हम लोगों को दिया हुआ है वेपर प्रेशर फॉर बेंजीन. ठीक है ना? Any doubts in this? Just do the calculations. Okay, 78/78 क्या है हमारा? ये है हमारा बेंजीन का वेट अपॉन मोलिकुलर वेट. ओके, देन 46 क्या ग्राम है? टोल्यून है. 46 ग्राम टोल्यून डिवाइडेड बाय मैंने क्या किया? उसके मोलिकुलर वेट. तो नंबर ऑफ, ये क्या मेरे एक्स बी मतलब क्या हमारा? नंबर ऑफ मोल्स ऑफ बी डिवाइडेड बाय नंबर ऑफ मोल्स ऑफ ए प्लस नंबर ऑफ मोल्स ऑफ बी. ये किया मैंने सिर्फ. ठीक है, आर यू गेटिंग दिस? और मल्टीप्लाई कर दिया उसको पार्शियल प्रेशर से जो दिया हुआ था हम लोग. ठीक है, और व्हेन यू डू दिस कैलकुलेशंस ना, यू विल फाइंड दैट अवर पीबी, ओके, जो हमारा पार्शियल वेपर प्रेशर आ रहा है एट 20 डिग्री सेल्सियस विल बी व्हाट? 50. जस्ट सिंपल कैलकुलेशन कीजिए, आपको आपका आंसर मिल जाएगा 52. राइट, नेक्स्ट. द इक्विलिब्रियम कांस्टेंट फॉर द फॉलोइंग रिएक्शन इज. तो यहाँ पे इक्विलिब्रियम कांस्टेंट का हम लोगों को कैलकुलेशन करना है. केसी दिया हुआ है, ठीक है. केसी हम लोगों को इक्विलिब्रियम कांस्टेंट केसी फॉर दिस गिवन रिएक्शन. सो केसी हमारा कैसा होगा इस रिएक्शन में? रिएक्शन देखिए क्या दी है. A2 plus B2 gives 2 times of AB. Kc is 60. करेक्ट स्टेटमेंट बताइए. So rate of constant for forward reaction will be equal to rate of constant for backward reaction. Okay. Next is what? Rate of constant for forward reaction will be greater and the rate of constant for backward reaction. Kf will be less than Kb, where value of equilibrium constant changes with use of catalyst. So here we need to find out what will be the answer. Okay, we need to find out what will be the answer here. So what do you think? What will be the answer? Yes, any answers? So यहाँ पे देखिए K/Kb कितना दिया है हम लोगों को? 60 दिया हुआ है. ठीक है, Kc कितना है? फॉरवर्ड रिएक्शन रेट डिवाइडेड बाय फॉरवर्ड इक्विलिब्रियम कांस्टेंट डिवाइडेड बाय बैकवर्ड इक्विलिब्रियम कांस्टेंट. ठीक है, तो वो कितना है? 60 है. तो 60 कब आएगा? ये ज्यादा कब आएगा? जब हमारा फॉरवर्ड ज्यादा होगा बैकवर्ड से. तो हमारा करेक्ट ऑप्शन क्या हो जाएगा यहाँ पे, ऑप्शन बी. Rate constant for forward reaction will be greater than the rate constant for the backward reaction. Yes, next problem. Aqueous solution of this and this are respectively. तो इन सब के जो aqueous solution हम बनाएंगे वो कैसे होंगे, एसिडिक होंगे, बेसिक होंगे, न्यूट्रल होंगे, बेसिक होंगे, एसिडिक होंगे, न्यूट्रल होंगे, दैट वी नीड टू कंसीडर. तो HCONO ये क्या है, सॉल्ट है. किसका सॉल्ट है, वीक एसिड का सॉल्ट है. ठीक है, इट इज व्हाट, सॉल्ट ऑफ वीक एसिड एंड स्ट्रॉन्ग बेस NaOH. ओके, यहाँ पे क्या है, ये NaOH से बना हुआ है और फॉर्मिक एसिड HCOOH से बना हुआ है. तो ये वीक एसिड है और ये क्या है, स्ट्रॉन्ग बेस. दैट्स व्हाई स्ट्रॉन्ग बेस उसमें प्रेजेंट होने के कारण ये कौन से नेचर में दिखाएगा हम लोगों को, सॉल्यूशन बेसिक नेचर में. सो दिस इज व्हाट, बेसिक इन नेचर. नेक्स्ट, व्हाट इज दैट, CCH5NH3Cl. दिस इज बीइंग अ सॉल्ट ऑफ वीक बेस एंड स्ट्रॉन्ग एसिड. स्ट्रॉन्ग एसिड इसमें कौन सा है, HCl, और वीक बेस कौन सा है हमारा, aniline. दिस इज व्हाट, aniline. दिस इज वीक बेस एंड दिस इज स्ट्रॉन्ग एसिड. तो ये एसिडिक होने के कारण ये इसका सॉल्यूशन कैसा होगा, इसका सॉल्यूशन होगा एसिडिक. इसमें एसिड प्रेजेंट है ना, स्ट्रॉन्ग, इसलिए ये एसिडिक होगा, ये बेसिक होगा. नेक्स्ट, KCN. KCN में क्या है, देखिए KOH हमारा स्ट्रॉन्ग एसिड है और उसके बाद HCN हमारा वीक एसिड है. ठीक है, स्ट्रॉन्ग बेस एंड वीक एसिड, स्ट्रॉन्ग बेस, सॉरी, दिस इज व्हाट स्ट्रॉन्ग बेस एंड दिस इज व्हाट वीक एसिड. तो स्ट्रॉन्ग बेस होने के कारण ये क्या होगा, बेसिक इन नेचर होगा. तो देखिए कौन कौन सा है, एसिडिक, बेसिक एंड basic, acidic and basic, acidic and basic. So option D, right? Option D will be correct answer here. Yeah, everyone, are you getting this? Yes? Okay, very good. So यहाँ पे ये सारे सॉल्ट दिए हुए थे हम लोगों को और उस सॉल्ट का हम लोगों ने डिस्टिंग्विश कर लिया कौन सा वहां पे स्ट्रॉन्ग एसिड प्रेजेंट है, उससे वो फॉर्म हुआ है, और कौन से बेस से इट हैज बीन फॉर्म, दैट वी हैव determined here, and with the help of which we have written the nature of the given solutions, aqueous solution. Next, the tetrahedral voids by CCP arrangement of Cl minus ions in rock salt structures are. So when we talk about the CCP arrangement, that is FCC arrangement, okay, closed cubic packing arrangement. When we talk in NaCl molecule, so you know that here what happens is that in NaCl structure, that is rock salt structure, Cl minus forms FCC structure, FCC lattice. यहाँ पे Na plus occupies octahedral voids. Okay, around Cl minus ion, whatever will be the octahedral void present, they are going to occupied by Na plus ions. So here, whatever the tetrahedral voids are present, na, they remain vacant. That's why they remain vacant. So here answer will be what? Cl minus ion, the tetrahedral voids will be vacant. So answer D is the correct answer here. Okay, next, acetic acid is obtained when. So when do we get acetic acid? That is our question. Methyl alcohol is oxidized with potassium permanganate. Formaldehyde is oxidized with potassium dichromate and sulfuric acid. Acetonitrile is hydrolyzed with a dilute mineral acid, and glycerol is heated with sulfuric acid. So here you can see the reaction when acetonitrile, okay, reacts or undergoes into hydrolysis, we get acetic acid. We get acetic acid. So that's why here answer will be what? Option C. Yes, everyone, any doubts in this? Yeah, next, dextrorotatory sugar present in fruits is. So you know in fruits, whatever the sugar is present, which is dextrorotatory, which is that? Yes, very simple, glucose, cellulose, fructose and starch. Yeah, can you tell me which sugar is that? Yeah, glucose. Okay, it is what? Glucose. Please remember this, right? Next, in the following reaction sequence, product Y will be. So here we need to find out what will be Y. So यहाँ पे हमारा अल्किल हैलाइड है, उसकी रिएक्शन केसिन के साथ कीजिए, वहां पे क्या हो जाएगा? ब्रोमीन का डिस्प्लेस हो जाएगा CnC. उसके बाद उसका डायल्यूट एस्टर के साथ रिएक्शन कीजिए, बॉइल कीजिए. यू नो दैट Cn का कन्वर्जन किसमें हो जाता है? COOH में. तो यहाँ पे 2 कार्बन और एक COH आ जाएगा, हम लोगों को क्या मिलेगा? एसिड मिल जाएगा. देखिए रिएक्शन कैसी हो रही है. C2H5Br reacts with KCN, Br undergoes into displacement और substitution with the CN. CN का आप अगर हाइड्रोलिसिस कर दोगे, हाइड्रोलिसिस करने के बाद, एसिड हाइड्रोलिसिस करने के बाद, you are getting what? COOH, that is propionic acid. So here option C is our correct answer. Right, everyone? Okay, very good. Now next topic, next problem. All monosaccharides containing 5 or 6 carbon atoms have. So what does they have? They have open chain structure, pyramidal structures, pyranose structures, may have pyranose or furanous structure. So you know all the monosaccharides. Okay, so you know they can have pyranose structure or as well as pyranose structure. So option D is correct option here. Very simple problem. Yeah. Next problem, last problem. The structure of the addition product formed when acetone reacts with the concentrated aqueous solution of sodium bisulfate. So this is very simple problem. यहाँ पे acetone की reaction यानी CH3CO CH3 इसकी reaction जब हम लोग किससे कर रहे हैं, acetone की reaction हम लोग सोडियम बाइसल्फेट, सोडियम बाइसल्फेट से जब हम उसकी reaction कर रहे हैं तो हम लोगों को क्या मिलेगा. So here you can see acetone when reacts with sodium bisulfate, we are getting this molecule. And what is it? Option D. And what is it? Option D. Yeah, is that correct? Any doubts regarding this question paper, everyone? Yes. If you have any doubts, you can tell me. So, do you understand this? Simple reaction है, show किया हुआ है मैंने already. ठीक है? Thank you so much for joining in. If you have any doubts, you can tell me.